Alright, let's start with number 3, as we oftentimes do. And don't let the parentheses mislead you. They're really not important in this case, because all we want to do is add everything that's in here. Okay, let's not even worry about what we're adding it to yet. We're just adding it to something. So we want to add 7x squared, and we want to add a negative 3, which is the same as subtracting 3. And we want to add it to this parentheses, which by the same reasoning, it is just 3x squared minus 5. There's nothing to do to the parentheses. There's nothing to distribute. There's nothing to divide by or anything. It just is a set of terms. So there's just really nothing the parentheses are doing. So we just want to add everything together, which means we want to collect like terms, which in this case, 3x squared plus 7x squared is 10x squared. We have two constant terms, and they total negative 8. So pretty straightforward. Just since you're just adding, you just want to add everything in these parentheses. There's just nothing to do. There's nothing that the parentheses need to be doing. They serve no purpose really, other than to group these together for some reason. Maybe they model something and then that has some significance. And let's go to number 6. And it's z squared plus 5z minus 7 plus 5z squared minus 11z minus 6. Okay, so again, parentheses, not really that important. So we're just going to pretend like they're not even there, and we're going to collect like terms. Z squared plus 5z squared is 6z squared. 5z plus negative 11z, those are common terms, like terms. It's going to be negative 6z. And a negative 7 and a negative 6, those are both constants, so we can collect them, and that's negative 13. Alright. So the only thing in this realm that offers much of a challenge is something like 14. Because it's subtraction. Right, now we want to subtract this parentheses. Okay, so that means we need to subtract everything in this parentheses. We want to subtract 3v cubed, and we want to subtract negative 12v squared, which is the same as adding 12v squared, and we want to subtract 8v. So we need to make sure to distribute that negative to everything. And now the parentheses would no longer serve a purpose. There's no need to group these together. There's nothing that we're trying to do other than make everything negative, and that's been done. So now we need to combine these two polynomials. 8v to the 4th doesn't have any common terms or like terms, so we leave it alone. Let's look for the next largest exponent. And then that 4 is the largest, 3 would be next, and it has no like terms. Next would be v squared. We got a v squared here and here. 12v squared minus 2v squared would be 10v squared. We got v and negative 8v, so it's negative 7v. And here's a constant, negative 4. So, there you go. Now let's do number 16. So this is the most basic of polynomials we could multiply by. It is just a single term. And I think I would hope that if there's like a 5 or a 7 there, you would know you're just going to distribute that to everything, and we've done that plenty of times. And that's the same thing we're going to do with x. We're going to distribute it to everything. We're going to distribute x here, and then to there, and then to the 7. So 2x squared times x would be 2x to the third, minus 5x times x would be 5x squared, plus 7 times x would be 7x. So we've distributed that x to everything in the parentheses, and that is all. That's everything that we need to do. And let's do number 19. And 19 is a slightly more complicated multiplying problem, where we may in the past have called FOIL, or said we're going to use FOIL, and that would be appropriate. It would absolutely work in this instance since we have 2 terms times 2 terms. But again, as I said in the intro video, let's forget about FOIL. Let's move, up in our level of understanding, and understand that all that we need to do here is distribute this to this, which means distribute everything in here, each term, to each term in here. So as long as we multiply this by everything in here and this by everything in here, we'll have done our due diligence. So we'll multiply 3z by z. That'll be 3z squared. And we'll multiply 3z by negative 3 and get negative 9z. And we'll multiply, now we're done. 3z is, we're not done completely. We're done with 3z. It's been distributed to z and to negative 3, and there's nothing else to distribute it to, so it has been paired up with everything that it can in this parentheses. Next we move on to 1 and do 1 times z. That's just z. And 1 times negative 3, that's negative 3. And we do have a like term here. So we'll put those together. Negative z plus z is going to be negative 8z minus 3. Okay, so slightly more complicated. We'll move from there to another level of complexity. We'll do number 20. And you'll see that hopefully this, or you'll agree, hopefully, that it was a good idea to get rid of FOIL, because it would just kind of hold us back. We would try to apply it to this situation, and it absolutely would not do the job. It would do the job incompletely. Specifically, if we followed the FOIL to the letter, we would never multiply anything by 6w. That's what would get left out. So FOIL is it just doesn't do enough. It was a mnemonic device that helped us remember how to multiply 2 binomials together, 2 things that have 2 terms each. Now we have 2 terms and 3 terms. So just going to make sure to multiply everything in here by everything in there. So we'll start with w. W times w squared is going to be w to the third. And then we'll use w again and move on to 6w. Make sure to multiply it by that. So we do 6w squared. And then we move on and multiply w by negative 11. That's negative 11w. And w now has been multiplied by everything in this parentheses. It's every pair that could possibly be made has been made. And so now move on to 4. And 4 times w squared is 4w squared. And then 4 times 6w, that's 24w. And 4 times negative 11, that's negative 44. And all we need to do now is collect like terms. And we will typically write them in order of highest power of w to lowest. So the highest one is 3. Highest power is 3. Next would be 2. So here is a w squared and a w squared. So 6w squared plus 4w squared is 10w squared. We got a w here, a w here. 24w minus 11w will be 13w. And we have minus the constant 44. Alright, so just make sure you multiply everything in here by everything in there. Let's do it one more time, but we will step it up another level of complexity. You see we have 3 terms times 3 terms. So now we need to make sure that all 3 of these get multiplied by all 3 of these. Okay, so let's have at that. Negative d squared times 3d is negative 3d to the 4th. Right, we got a negative, because we got a negative times a positive, and d squared times d squared is d to the 4th. Okay, next, negative d squared now needs to get paired up with negative 7d. So that's negative times negative is a positive, 7d to the 3rd. And now we move on to the 6. Negative d squared times 6 will be negative 6d squared. And now we've taken negative d squared and multiplied it by everything in here, everything that's possible. So negative d squared has been distributed, and next we'll distribute the 4d. 4d times 3d squared is 12d to the 3rd. 4d times negative 7d, that's negative 28d squared. And 4d times 6 is 24d. And now 4d has been distributed to everything here. And so now we need to move on to 3, and now I've drawn arches at the top and the bottom, and it's getting a little crowded. But we'll try and make them distinguishable. We'll make them square, like that. So 3 times 3d squared is going to be 9d squared. And then we multiply 3 by negative 7d, and we get negative 21d. And lastly, we multiply 3 by the 6, and we get 18. That's it. Just 18, a constant of 18. So it takes a lot of work. We have 3 things multiplied by 3 things. We get 9 terms here, which is a good check to make sure you've multiplied everything out. You'll have this times this many terms. Here we had 9 terms, here we had 6 terms, here we had 4 terms, here we had 3 terms, and that's just a little check to make sure you have done it correctly. Okay, so here's another place where you just need to take it slow, pay attention to the details. Let's look for the highest power, which is 4. That's the highest one we see. And there's no common or like terms with d to the 4th, so that's it. Okay, and with something this long, I like to just underline or cross it out just to know that I have moved it down to this next level. Next, we'll go on to the next highest power, which is 3. And here's one, and that's it. So we'll put those together. 7d to the 3rd plus 12d to the 3rd would be 19d to the 3rd. Okay, so those have been put together. It's all down here. That's taken care of. Next we have squared, squared, and another squared. So we've got 3 of those to put together. We've got negative 7d squared and negative 28d squared. Okay, so that's negative 34d squared. Okay, negative 34d squared plus 9d squared is negative 25d squared. Okay, and mental arithmetic is not my strong point, so just double check that. That's correct, negative 25d squared. Check in with the teacher's manual as we fly through this. And now we have 24d and negative 21d, so that goes together to make 3d. Those have been put together, and we have our single constant. There we go. Everything has been put together, and everything has been the like terms have been collected. So we're all done with that problem. All right, so let's move on to number 28. And we have 3 things to multiply together, 3 separate parentheses. And the question may come up in your mind, how do we do that? How do we multiply 3 things together at the same time? And the easiest answer is don't multiply them at the same time. Just do what you know how to do, and do it over and over. What you know how to do is multiply 2 sets of parentheses together, So let's do that, and then we'll do it again. And we'll do it as many times as we need to multiply all of the parentheses together. Okay, so we're multiplying 3 binomials. It's 3 things that have 2 terms each. So let's do this first one, and I won't draw all the arrows and stuff this time. I think you can follow along pretty easily. So x times x is x squared. And now x times -6 is -6x. Now x has been distributed, it's done. So let's distribute the 4. 4 times x, and 4 times -6 is -24. So we have this term, we're multiplying by x minus 5. Let's collect these like terms here. We get x squared minus 2x minus 24 times x minus 5. Okay, so now we need to distribute everything in here to everything in there. Just a couple quick notes. We could have multiplied these two together if we wanted to. We actually could have multiplied this first binomial and this last binomial together if we wanted to. The order doesn't matter because multiplication is commutative. We now have the choice of multiplying this by that, right? We could multiply from left to right, where this is on the left and this is on the right. We could put this over there. We could move x minus 5 in front, and we could multiply it in that order. And we could also multiply anything in here, in any order. We could start with -2x. We don't have to start with x squared. So all I'm saying is that the order is not important, and that is a useful thing to somebody who would rather multiply x minus 5 by this, distribute the x and the -5 through these 3 terms rather than distribute these 3 terms to these 2 terms. You can do it in any order that you want to, as long as you do everything. Okay, but I'm just going to do it in the way that it came up. It came up just like this. So we'll do x squared times x. That'll be x to the 3rd. And now we need to do x squared by -5. That's -5x squared. Okay, now x squared has been distributed to both of these terms, so we move on to -2x. We get -2x squared. And we get positive 10x. And we move on to -24. Just like that. -24x. And let's see, positive 98. I believe, no, not 98. It's 120. Okay, now we're going to collect like terms if possible. The x to the 3rd has no like terms, so it stays by itself. That's taken care of. We have x squared terms here, so we get -7x squared. And those are put together. Now we have 10x minus 24x, that's -14x. That's done, and we have a constant of 120. Alright, so, and for all of these, multiplying 3 binomials, that's all you need to worry about doing. Just multiply 2 of them together, and then you get something like this. I'm using my hands, and you're not able to see that. You get this guy right here, and then you just distribute everything in there to this, and collect like terms. It's just a process that's important, and you pay attention to the details. So watch out for them details. Now let's move on to number 38. Actually, we'll do all 3 of these. They're kind of similar to each other. We're going to multiply these 2 together, so we get x times x is x squared. X times -5 is -5x. Okay, we distributed the x, now move on to the 5. 5 times x is 5x, and 5 times -5 is -25. Now we wound up with a -5x and a positive 5x, so they're going to cancel each other out, so we'll get x squared minus 25. Okay, that's it. Now this situation right here, and this one likewise, if you could remember, always, if everyone could always remember that this 2 up here in the superscript, right, up here above the rest of it, means multiply this, right, whatever it's above, including everything that's in the parentheses, multiply this by itself. If everyone could always remember that, it would make my heart quiver with delight. It would just be so great if we never had any misunderstanding about that. Okay, so since this means multiply this by itself, multiply this by itself. Okay, that it seems obvious, and it is obvious, and I hope it is always obvious and there's never any confusion. The problem is what people try to do is square this and then add the square of this. It's just too simplistic. It doesn't work that way. This means multiply it by itself, which means you have to do all this work. So you got 4c squared plus 10c plus another 10c plus 25. We collect like terms, and we get 20c plus 25. Okay. So, like I said, it would just make me immensely happy if we could just always remember what this 2 means. It means, I think that it's not so much confusion as just not wanting to admit to ourselves that there's more work than we want involved. You gotta multiply this binomial by itself. Likewise, this is even more work than we want to do, but it just is what the situation calls for. We raise the parentheses to the third. It means take that parentheses, multiply it by itself, not 2 times, but 3 times. That's what that 3 up there means. So that's what we need to do. So we'll multiply these 2 together. We'll get 49x squared minus 7xy. Let's see. Then we move on to the negative y, and we get negative 7xy again plus y squared. So we get negative y times negative y. Multiplying that by 7x minus y. 49x squared minus 14xy plus y squared. Alright. Now I'll challenge you to follow along. I won't draw any arrows or use color coding or anything like that. I'll just point to what we're doing. We're going to multiply 49x squared by 7x. And let's make sure we get that correct. 49 times 7. 343. 343x to the third. X squared times x gives you x to the third. 49x squared by negative y is negative 49 x squared times y. Okay, so this has been distributed. It's going to take up a lot of room here. Now we'll move on to the negative 14xy. Negative 14xy times 7 is 49, 98. So 98 x to the third. And now we'll move on. Oh, sorry. Let's see where I messed up there. We were doing negative 14 times 7. So it's a negative 98. Xy times x would give us an x squared y. Negative 14 times negative y, or negative 14xy times negative y, is positive 14xy squared. And now negative 14xy has been distributed to both of these terms, and we move on to y squared. It's going to give us 7xy squared minus y to the third. Alright, and now let's look. I don't think we'll have like terms, maybe. Oh, okay, no, we do, right here. These 2 are like terms, these 2 are like terms. So let's do that. 343x to the third. Okay, that's taken care of. And so how this works, the order that we write this in usually is we'll go in descending order of the powers of x, and then y will just kind of tag along. So next, x squared is the next one in line, so we'll use that. And let's see, negative 49 and negative 98. Let's just do that real quick. 49 plus 98, and we'll just make it positive, or make it negative, negative 147. Negative 147x squared y. And 14 plus 7, that's 21 xy squared minus y to the third. So we did get all of those, and there. And that's taken care of. All right, just a couple more here. We'll go to 48. Okay, so 48, I'm just going to draw this really rough. We have a what's called a rectangular prism. And we want to know the volume of it, or we could call it a box if we wanted to. So the height is x plus 3, and x is just the depth of this box. And then if we want to know the length, we just take x, multiply it by 3, and add 1. And what's the volume of this box, or what's an expression that gives the volume of this box? So there's a box somewhere, and it doesn't have any specific measurements as of yet, but we do know that there's these relationships between the depth and the height and the length. Where if you know the depth, you can take the depth and add 3, and that'll give you the height. You can take the depth and multiply it by 3 and add 1, and that'll give you the length. So to find the volume of a box, we multiply the length times the, I guess what I've been calling depth, we could call width, and multiply that by the height. So you take the length times the width times the height, side times side times side. So this volume will be 3x plus 1 times x plus 3. Okay? So let's multiply, just to show you that it doesn't matter, we'll multiply these two first. So you got 3x plus 1, we're going to multiply that by what we get here. That's going to be x distributed through here. That's going to be x squared plus 3x. Now we're going to multiply these two together, so we'll just go from left to right. It's the easiest way to keep track of everything. So 3x times x squared is 3x to the third, plus 3x squared. We're going to multiply the 3x's together. And we'll multiply 1 throughout, and we get x squared plus 3x. We do have like terms here, so we'll go 3x to the third plus 4x squared plus 3x. And that is an expression that tells us the volume. If we knew what x was, we could just plug it into all three of these, and that would give us the volume. Okay. So a similar problem is number 60. This is a word problem. And they give you these two equations. And to make sense of these two equations, the thing that comes to mind first to me is, what is d, what is t, and what is p? And there's t again. So again, the question is, what is t? So if we read the the little couple sentences, or one sentence above where we find those, it says in 1999 to 2004, the number of DVD players, D. So D is the number of DVD players. Okay, so I'm not sure what T is still, but D is the number of DVD players. So that's good to know. Players. Okay, so that's good to know. In millions, so if the output of this function was 7, that would mean 7 million DVD players. Where are we looking now? So in millions sold in the United States, the average price per DVD player P. Oh, okay, so that's what P is. P is the average price of. I got so excited I didn't finish reading that. The average price per DVD player. So average price of a DVD player. Modeled by, and they tell you these two equations and say where t is the number of years since 1999. So t is the number of years. Number of years since 1999. Okay, so if t were 1, that would mean the year 2000, because that's 1 year after 1990. If it were 2, it would be 2001, because that would be 2 years after 1999. And t is the same thing over here. It's still the number of years since 1999. Okay, great. So that ups our level of understanding of the situation. And it says write a model of the total revenue R from DVD sales according to the model. What was the total revenue in 2002? So we have a couple of questions there. First, we want to write some kind of a function, R, revenue, the amount of money made on the sale of DVD players. So we want some function over here that we can plug t into and know how much money was made. How could we possibly do that? Seems like a total mystery. But we know something about the number of DVD players and the average price of a DVD player. So let's say that there's some year out there and they sold, and this is in millions, remember that, in millions. So I don't know, it's a reasonable number of millions of DVD players to have sold. So let's say 50. Okay, let's say they sold 50 million DVD players. We know that. And we know that a DVD player costs, say, $30 on average. So what do we do with these two pieces of information? 50 DVD players. Let's just put DVD. And $30 for a DVD, so per DVD player. So what do we do with that? Well, there's 50 of these. Each one of them costs $30. So if you take 50 times 30, then we'll have 1,500. So, except for this is in millions, so this is 1,500 million. So that comes out to be 1,500,000,000. Okay. So the lesson that we learned is you just take the number of DVD players times the cost per DVD player, and you have the total revenue. So that's what we'll do. We'll take the number of DVD players times the cost per DVD player, and we'll get the total revenue. So revenue will just be D times P, the number of DVD players times the average cost per DVD player. Of course, that means taking this expression and multiplying it by that one. You get 4.11 t, stand by. Alright, so you have these two expressions that we're supposed to multiply together, and since we have so many decimals and craziness, let's pull out our calculator. Alright, so R is equal to 4.11 times 6.82. 28.03, let's say. 28.03 t to the third. And then we'll do 4.11 times 61.7. $253.59. Oh, that's going to be negative. Before I forget this number, let me just write it down. And this will be a negative number here. And then 4.11 times 265. So I need to figure that out. $1,089.15 T. Oh, and I apologize. I forgot the variable over here. This is when we did 4.11 times 61.7, and then we have t times t, so that's t squared. My apologies. Next, we'll move on to 4.4 and distribute it. So we'll do 4.44 times 6.82. 30.28. And that is going to be positive. 30.28 t squared. And then we will do 4.44 times negative 61.7t. So we should get a negative 273.948. 273.95 times t, because we have a t here. And 4.44 times 265. 4.44 times 265. 1,176.6. 1176.6. And it's just a constant. Okay, now we'll collect like terms. This is the only one of its kind, a t cubed. And there's a t squared and a t squared. So we have 30.28 from right here, minus, because this is negative, and we're doing this because they're both t squared terms, minus 253.59, negative 223.31, t squared. So these are done, this guy's done, and next we have the t terms. Let's get this out of the way. So 1089.15. Minus 273.95. $815.2. 815.2. All right, t, because they are t terms. They've been taken care of, and we just have the constant of 1,176.6 left. And good, that's all taken care of. That is a function that if you put in t, something for t, which is the number of years since 1999, it'll tell you how much money they made in that year on DVD players. And they want to know in 2002 how much was made on DVD players. So, let's see. Yeah, 2002. So, how does 2002 translate into T? Well, it's years since 1999, and 2002 is 3 years since 1999. And so, there we go. We need to put a 3 in for T. So, I'm going to get my graphing calculator to do all of this. It's just the right tool for the job. Quit that there, clear that out. So, let's put all this in, making sure to put in 3 for t. So multiply times 3 to the third. And then we'll subtract 223.31 times 3 squared plus 815.2 times 3, just a 3, plus 1176.6. We get 2,369.22 million dollars, because remember that in part of this multiplication we were multiplying by D, which is DVD players in millions. So the dollars that we get is in millions of dollars. So $2,369.22 million, or let's see, what are we doing here? Yeah, $2,369,000,000 in sales of DVD players. Crazy. Lots of money. None of it mine. So that's it. I hope that was helpful. Thanks a lot for watching.